Hello everyone, it's Mr. Salimata over here, and in today's lesson we'll be looking at exact trigonometric values of the angles 30, 40 and 60 degrees. And by the end of this lesson, every student should be able to derive and use the exact values of sine, cos and tan for 30, 45 and 60 degrees. Yes. Okay. So now, if you remember in our previous lesson, we did use the phrase sarcator to help us find the missing side and angle in a right triangle. Yes. So let me just write that phrase right here. Yes. Sarcator. Yes. So this is the phrase that we used to what? To help us find the missing side and angle in a right triangle. Yes. And we're also going to use this same phrase over here to help us find the exact values of sine, cos, tan for 30, 45 and 60 degrees. Yeah. Okay, so now let's get into this lesson by first looking at the exact value of sine 45, cos 45 and tan 45. Yes, so allow me to write them here. Okay, so sine 45, cos 45, yes, tan 45. Yes. Okay, so now let's start our lesson by drawing a right triangle. Yes, I don't have a ruler, so my right triangle might not be drawn perfect. Yes. Okay, I'll try my best to do that, to just draw it. Yeah. Okay, so let's say we have this right triangle over here. Yes, and let us try to give any of these two angles. Let's give it angle 45. Yes, let's give it 45. Let's start with this angle over here. So this is my 45 degrees angle. Yes, and we do know that all angles in a triangle add up to 180, right? So that means our other angle there will be 45 as well. Yes, this angle over there will be 45 degrees as well, right? Okay, so now, what is it that you guys can notice with this triangle over here? Yes, you can notice that it has what? It has two equal angles, right? It has two equal angles over here. Yes, and if a triangle, yes, has two equal angles, yes, what then do you think will happen to these two sides? Yes, think about that. So these two sides will also what? Will also be equal, right? So this side over here and this side over here will be what? Will be equal. And if we have two equal sides, yes, and two equal opposite base angles, what triangle have we just formed right here? It is an isosceles triangle. Yes. Okay, now that we have that information, so how about now we give this side and this side a unit of 1? Yes, you can give it a unit of 2, you can give it a unit of 3, but for me, I would advise you to give it a lesser unit. Yes, because it is easier for calculations. Okay, so let's give it a unit of 1. Yes, so we have 1 over here and 1 over there. Yes, now we have a missing side right here. Yes, we also have to find the value of this missing side over here, and we're going to use the Pythagoras theorem. Yes, we're going to use Pythagoras theorem. Yes, and for those of you who are maybe struggling with Pythagoras theorem and want to know about Pythagoras theorem and how to solve or go about the Pythagoras theorem, please, I have done a video about that. you can go and check it out, and then know how we can use the Pythagoras theorem. Okay, so now for us to find the missing side here, we're going to use the Pythagoras theorem. Yes, and we do know that A and B are the two legs over here. Yes, these two legs, and C here is what? Is the hypotenuse, the longest part of a triangle, or rather of a right triangle, and it is also opposite the right angle. Yes, so then what does that tell us? Yes, you can, if you want, you can label them as this one as your A. Let me use my blue marker. I can label this part as my A and this part as my B. Remember, the hypotenuse doesn't change. Yes, the hypotenuse doesn't change. What I mean by that is you can label this one as your A and this one as your B. That's not a problem. But for the hypotenuse, it always has to be a C. Yes, it doesn't change. You cannot swap. You cannot say this is your B and then this is your C, or this is your C and that's your A. That doesn't work. Yeah. Okay. So let's remember that. Let's not forget that. Yes. Okay. So then now, using our Pythagoras here, we can see that our C is missing, right? So we have what? We have 1 squared plus B. Sorry. We're now substituting. Yes. We're just substituting the values. Yes. So our A is 1 squared. Yes. And our B will also be 1 squared equal to C squared. Yes, now we have to find the values. Yes, the values of 1 squared. Yes, the value of 1 squared. 1 squared is what? Is 1. Plus the value of what? Another 1 squared is 1 equal to C squared, right? 1 plus 1, that gives us 2 equal to C squared. What will be our next step? Our next step will be what? Getting rid of that index over there, or we can also say exponent, yes? By just square rooting both sides, yes? And that will go, right? So our C value then, yes? Our C value then becomes what? Square root of what? Of 2, right? So we take that out, yes? And this value right here will be the square root of what? Of 2. Yes? Okay, now we have the sides. Yes? And this here is a what? Is a special triangle. Yes? It's a special triangle. So this triangle, we call it 45, 90 angle. Triangle. Okay? So, and yes, it is what? It's 1, and the square root. Yes, square root of 2. Yes. Okay, so this is our first triangle that we are going to find the what? The exact values of. Yes. Okay, so now that we have this information over here, let's now find the exact value of sine 45. What are we going to use? We are using this phrase SOHCAHTOA. Yes, and we know with sine it's going to be what? Opposite over what? Hypotenuse, right? Now, if you look at this this triangle over here, we have both angles that are the same, right? And same length. So it doesn't matter. Yes, it doesn't matter which angle you choose between the 245 to use in labeling your right triangle. Yes, so let's say, for example, yes, I'll choose this angle over here, right? So I know that the longest part here is my hypotenuse, right? Is my hypotenuse. Yes? Okay, since I'm using this angle, so the opposite side right there, that will be my opposite. Yes? And this other part here will be my adjacent. Yes? Okay, so then, if we know that sine, yes, if we know that sine is what? Is opposite over hypotenuse, yes? So, yes, opposite, yes, we're using opposite over hypotenuse, yes, and using our triangle over here, yes, using our triangle over here, we know that our opposite is 1 and our hypotenuse is what? Square root of 2, right? Okay, so now we don't want to have a denominator with a square root. So we have to what? We have to rationalize our denominator by just simply, yes, multiplying our denominator by square root of 2 and our numerator by square root of 2, and that will give us what? That will give us, I'll do it in a very detailed way. So we're going to have that, yes, right? And if we multiply these two, that will give us what? That will just give us root over there, yes, square root of 2, and these two will give us what? Yes, square root of 4, and we're going to have square root of 2 over, what is the square root of 4? That's 2, right? Okay, so then we now know, yes, we now know that sine 45 is what? Is square root of 2 over 2. Yes, so now let's now try to find cos 45. Yes, the exact value of cos 45 in the same way that we have found the exact value of sine 45. Yes, okay, so now for cos, yes, we're going to use this part over here on the middle. Yes, so it's adjacent over hypotenuse. Yes, adjacent over hypotenuse. Yes, and we know that our adjacent is what? Is 1. Yes, our adjacent is 1, and our hypotenuse is what? Our hypotenuse is 2. Yes, okay, so then what are we going to do? We have to what? We have to rationalize it, right? Okay, we do the same. Yes, and what are we going to have? We'll have yes, and that gives us what? That gives us square root of 2, square root of 4, and we have our square root there, over there. Yes? Okay, so now let's find tan. Yes, now let's find our tan 45 over here. So we know tan 45, we know that our tan, using our SOHCAHTOA there, is what? Is opposite over adjacent, right? And we know that our opposite is 1 and our adjacent is 1. Yes, and this is like an easy calculation. Yes, because 1 into 1 is 1. So the exact value of tan 45 is 1. Yes, so this is how we find the exact value of the exact values of sine 45, cos 45, and tan 45. So now we know the exact value of sine 45 is root of 2 divided by 2. Cos 45 is root of 2 divided by 2. Tan 45 is 1. Yes? Okay, so now that we found the exact value of sine, cos, tan of 45, our next will be finding the exact value of sine, cos, tan of 30. Yes? So, allow me to write them here. Yes? What we're finding, sine 30, yeah, cos 30, and tan 30. Okay, and how are we going to do that? We're going to use our SOHCAHTOA over here. That will also help us to find the exact values of sine 30, cos 30, and tan 30. Now, let's start this segment by looking at an equilateral triangle. Yes, so let us draw an equilateral triangle. Yes, so let's have our equilateral triangle over here. Yes, okay, now what are some of the properties of an equilateral triangle? We do know that an equilateral triangle has what? Equal sides. Yes, so it has equal sides, right? And we do know that it also has equal angles, yes, which are what? 60 degrees. Yes, so this angle is 60 degrees. Yes, this angle also 60 degrees, and that angle over there 60 degrees as well, right? And if it has equal sides, yes, let's give each equal side a unit of 2. Yes, let's give each equal side a unit of 2. Yes, a unit of 2. Each equal side a unit of 2. Yes. Now, how about then? Yes, how about then we draw a perpendicular line from the top, the vertex, yes, down to the what? To the midpoint base. Yes, let's do that. Okay, so this is our perpendicular line, yes, from the top vertex, yeah, down the midpoint of our what? Our bottom part over there. Now, if we look at what has just happened here, yes, our perpendicular line over here has what? Has divided our equilateral into two congruent triangles, right? So then, what has happened to our top angle over there? So, it has divided our angle as well, right? So that means, yes, so that means this part over here, yes, this small part here will be what? Will be angle 30, and that other angle there will also be angle 30, yes, and it has formed a 90 degrees and a 90 degrees over there, yes. Now, what has happened to our bottom part here? So the whole unit is 2, right? But our perpendicular line has what? Has separated it or has divided it into what? 2 congruent triangles, right? So let's just do this. The whole of this part has a unit of 2, right? But it's been divided, yes, into congruent triangle. So then triangle. So we can say that this part, yes, until this part, and this part to this part is 1 and 1. Yes? Okay, so then let's now take this right triangle over here. Yes? Let's take it. I'll just draw it for visual. Yes? So it's like that. Sorry. Yeah? Yeah, and we have our 90 over there, right? And we have our 30 degrees and our 60 degrees over there, right? And remember, this is a unit of 2 and this is a unit of 1. And this right here is our height, right? Which we don't know, right? And for us to find this height, we use our what? Our Pythagoras theorem, right? So a squared plus b squared equal to c squared. And we know that the longest part, which is opposite the right angle, is our what? Is our hypotenuse, right? So that would be 2 squared equal to, right? Okay, so if this is my a and this is my b, so my h will be just like h squared plus my b is 1 squared, right? And we'll be left with h squared plus 1 squared is what? Is 1 equal to 2 squared is what? Is 4, right? Okay, so now we isolate our h squared by just subtracting by 1, right? Those two will cancel out and we shall be left with h squared equal to 4 minus 1 is 3. Let's isolate our x by getting rid of the index or the exponent. So we just square root that and square root both sides. Those two cancel out and we have our h equal to root 3, right? So this type of triangle is a what? Is a 30 to 60, 90, yes, with what? It's a 1 square root of 3 and 2. Yes, so this is this special right triangle over here, right? Okay, so now our next part over here, sorry, allow me to get rid of that a that h because we already found the value, which is root of 3. Yes. Okay, so now our next part is now just finding the exact values of what? Of sine 30, cos 30, and tan 30. Yes? Okay, now remember, what angle are we finding? 30, right? So, Our opposite, this is the angle that I'm using. So the opposite will be our what? Will be our op. Yes, we know the longest part, which is opposite the right angle, is our hypotenuse, and our remaining side will be what? Will be our adjacent. Yes? Okay, so now, how then do we find sine 30? Using our Sakatoa over there, we know sine is what? Opposite over hypotenuse, right? And our opposite is 1. And our hypotenuse is 2. Yes? So, the exact value of sine 30 is half, 1 over 2. Yeah? Now, let's find our exact value of cos 30. Yes? And using our Sakatoa over here, we're using our mid part. So, that's what? Adjacent over hypotenuse. Yes? And our adjacent, our adjacent over here is what? Root 3, or rather square root of 3. Yes? And our hypotenuse is 2, right? So there we go. We have found our what? Our exact value of cos 30, which is root 3 over 2. What about our tan? Tan 30, our last part over here, which is what? Opposite over adjacent. Our opposite is 1. Yes? Our adjacent is root 3. Yes? Now, you can leave it the way it is. Yes? You can leave it the way it is. But in higher math, I would advise you to rationalize the denominator, because we don't usually want to have a square, yes, a square root as a denominator. Yes? So let us rationalize that. Yes? By just what? Multiplying the denominator and numerator with root 3. Yes? In details, 1 by root 3 will have square root of 3 over there, and root 3 multiplied by root 3 will have what? Root 9. Yes? And so our final answer will be what? What's the square root of 9? Is 3. Yes? So this is the exact value of tan 30. Yes? Okay, so now allow me to just erase this part. Yes? I'll let you know the reason why I want to erase it. I've left my eraser somewhere there and I don't want to move, so I'll just use my hand. Yes, excuse me about that. So, yeah, okay. So we have found the value of what? The exact values of sine 30, cos 30, and tan 30. Now, I'm sure you guys are asking me, or rather wondering, why is Mr. Salimata just erasing everything immediately, right? It's because I want us to now find the exact value of what? Of sine 60, cos 60, and tan 60. Yes? So now we are finding the value of what? Sine 60, yes, cos 60, and tan 60, right? And the reason why you didn't see me erase the other part, yes, is because we are going to use this same triangle to find sine 60, cos 60, and tan 60. Yes, we're going to use this right triangle here to find the exact values of these three over here. Yes, and if you look at it, yeah, if you look at this right triangle over here, yes, we are finding what? The exact value of sine 60, yes, so we're going to use this angle right here, right? Okay, so then, in our case, if we want to label it, we have to change, yes? The sides will change now. Yes, that changes now. Only these two actually, the hypotenuse just remains the same. Remember, it doesn't change, right? Okay, so now, this, because we're using 60, this now will be our opposite, and this will be our adjacent. Yeah? Okay, so now let's find our what? Let's find our sine 60, our exact value of sine 60. Yes? Okay, so now sine is what? Opposite over hypotenuse. Yes? And in our case, what's our opposite? It's root 3. Yes? And what's our hypotenuse? It's 2. So we have found the exact value of sine 60. Yes? Okay, so now let's find the exact value of cos 60. Cos, yes, that's adjacent over hypotenuse, right? What is our adjacent? Yes, adjacent is what? Is 1. Yes, our hypotenuse is 2. So then cos 60 is half. Yes? Okay, so let's move on to our last one, tan 60. Yes? And we know that tan, using our SOHCAHTOA there, is opposite over adjacent, right? Opposite over adjacent. And what is our opposite? Root 3 over, what is our adjacent? 1. And we know that 1 into root 3 is what? It's simply root 3, right? So there we go. We have found the exact values of sine, cos, tan for 60. Yes? So in this lesson, we have learned how to find the exact values, yes, of sine, cos, tan for 30, 40, and 60 degrees. Yes? Okay, thank you so much for tuning in into today's lesson. I'll see you in my next lesson.